Hi, this is Kim Breeden at Minnesota Online High School. Let's learn about similar triangles. We can think about similar triangles as images that have the same shape, but they're not necessarily the same size. So what this means in similar triangles is that we have three pairs of congruent angles. And we have three pairs of sides that are proportional. That means that if we pair up the sides and reduce them as fractions, they're all going to be the same. Now, when we write our similar triangles, we use this as our symbol. It looks kind of like just the top part of what was in your congruent. Now, fortunately, we don't have to check all 6 pieces of information in order to know if triangles are congruent. There are 3 shortcuts. So in this video, we're going to cover the 3 ways to prove that triangles are similar. Angle, angle, side, 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 angle, side. Now, these might sound familiar. We did similar things with congruent triangles. Our first way to know if 2 triangles are similar is called the angle-angle similarity theorem. And this means that if we have 2 pairs of congruent angles, then our triangles are going to be similar. So looking in this picture, we are told that angle N is equal to angle R, and angle O is equal to angle P. Therefore, we can write a congruent statement. So triangle MNO is congruent to triangle QRP by angle angle. Remember, just like with congruent triangles, when we name the triangles, we need to make sure that the equal parts are in the same spot. So we know that angle M and Q are equal. They're the first letter in both names. Our second method is side, 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 or SSS similarity theorem. In order to use this, we need to know that we have 3 pairs of proportional sides. This means we pair up the corresponding sides. We can turn them all into a decimal by dividing, and all 3 of those have to be equal. When you set them up, make sure that you're pairing the smallest one from the first triangle with the smallest from the second. So for example, the 5 over the 4. Then I often recommend going the biggest with the biggest. So 13 over 10.4. And then that leaves 12 divided by 9.6. So fraction means divide. So on your calculator, if you take 5 divided by 4, 12 divided by 9.6, and 13 divided by 10.4, you'll get the same decimal, 1.25. Since those are all equal, triangle ABC is similar to triangle DFE by side, side, side similarity. And our last one is kind of a combination of the 2. It's called side angle side similarity theorem. To use this, we need 2 pairs of proportional sides and the congruent included angles. So first, let's start by setting up our fractions. So we're going to do the smallest side with the smallest side, so 5 over 7.5 and 7 over 10.5. Divide that on your calculator. Those both equal 0.6 repeating. So those are proportional or equal ratios. Now we don't know information about that third side, so we cannot use side, side, side. But we have that angle, the included angle. It's made by those 2 sides we know, and we have a pair of equal included angles. So this means triangle GHI is similar to triangle LKJ by side angle side. Let's try a couple examples. You might want to pause this and on your own determine if these triangles are similar. I see right away that I have a 59-degree angle here and here, and then I have a second pair of equal angles, 34 and 34. I'm missing this third angle. Why? First off, remember, you could find it because the sum of the angles is 180. So if you need to find a missing angle, subtract from 180. But we don't need it. We only need two pairs of equal angles. So by the angle-angle similarity theorem, we're going to have that triangle TUS is similar to triangle XYZ. How about this one? Are these triangles similar? Okay, I notice that I have pairs of sides. So I have some side lengths. And let's go ahead and let's check out if the sides are proportional. So 15 is the longer side. So I'm going to pair that with 4, which is longer. So 15 over 4. And we're going to see if that equals 9 over 3. Okay, so use your calculator. 9 divided by 3, well, that is just 3. 15 divided by 4, however, is 3.75. Okay, so those sides are not proportional. Even though I do have these vertical angles that are equal, I don't have enough information. So I do not know that those are similar. So not similar or not enough information. And finally, here we have some overlapping triangles. I think this is easiest to do if we separate them out. So that top angle is there, but then I have 20 and 25. Okay, so then that bigger triangle, that whole side would be 44. And the right side is 55. Okay, I know that top angle's equal. So let's go ahead and let's set up our fractions. So if we take 20 divided by 44, and then 25 over 55, let's see if those fractions are equal. 20 divided by 44 is 0.45, repeating. 25 divided by 55 is also 0.45, repeating. Okay, so I have two pairs of proportional sides. I also have the overlapping reflexive angle. So that means that yes, these are similar by side, angle, side.